Hi, folks. Matt Hoiser here. We've been talking about secrets of software testing, and by secrets, I don't mean it's whispered in the corner. Don't tell anybody. But as an industry, we keep acting as if we don't know that these things are true. We keep forgetting about them. They are discovered, but we seem to have so much turnover and so many new people coming up, or so many people transferring in from the top and driving influence in organizations. We just don't act as if these things are true, but they're fundamental. So I've been talking about how testing, it's good testing is fun. And we keep driving the fun out of it and then wondering why we can't attract people that are any good. It's easy to go meta on this. Oh, we don't pay enough. Or we don't have good enough education. We select the wrong people for the. All those things are true, but I'm unlikely to get them fixed in this video. So I want to focus is on things that can be driven more bottom up, where the practitioners can influence the change. Uh, and they should be within our discretionary authority. So, ways to make the work fun. Let's talk about the nature of the work. So, many people that talk about testing talk about test cases. So, a test by that, it would be written down by someone else and handed to me, and it would be something like launch browser, go to this specific web page, log in these specific credentials, find the search button, click on the search button, type in this thing to search, click the search button. I'm bored telling you about it, and I haven't done anything yet. I haven't done the actual testing yet. But finally, eventually, we get to something. Type in these values, click these things, there should be a transformation, we should see this result. And usually there is an expected result there. It's stored somewhere. Maybe it's in Jira. Maybe it's in some other tracking system, right? It's usually online somewhere. And there's an expected result. And there's a hidden assertion in there, I think, that humans are pretty good at figuring out, which is verify that nothing odd happened during the entire journey. We don't talk about that enough. If I made a list, if we tracked it to the percentage of bugs that are found not an expected result, but they're found in some unexpected result, part of the test, and we could weigh them by how important they are, the vast majority of important things would be off script defects. That's a problem. And I know of one organization where they wanted every defect to track back to a test case with an expected result, and it was a regulated industry, so they had a reason for wanting it, and the team couldn't do it, and they ended up driving out some of their best people. There's a problem with this because what we call inattentional blindness. I'll have a link in the description so you can read about that. So, and what inattentional blindness is when you're laser focused on the thing and you don't see anything else around you. So when I start talking about finding defects off script, if our goal is to be efficient and effective at executing scripts, and we're going to laser focus on it, we're going to miss all of the things that are off script. That's a problem. When you have the more we focused on process improvement, on following the process, the more we're going to miss the things that we know empirically are important. Then you have automation. So with traditional click, 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 check, inspect automation, and I'm looking for a term for that if someone has a better way to say it, that problem isn't a risk, it's a guarantee. Because the code only says make sure that this matches that. That's it. You know, if it crashes the whole web page, it won't be able to click the next thing, and you'll get lucky. So you get some of those big we crash the web page problems. But frankly, today I'm not seeing that nearly as often as I was 10 years ago. Code is coming out of the gate in higher quality. The defects we find, we're not finding as many sweep the floor defects that anyone could find um, on our build. So you say, but Matt, what's the alternative? Well, there's a couple of alternatives. One is to make sure the whole page looks exactly like you want it to. But then the job of the programmer is to create change. So you're gonna get errors every single time the programmer makes a commit, pushes it, gets a new build. You're gonna get errors. You shouldn't be getting errors in just about every build. Just about every build. So it's no longer test automation at that point. It's change detection. So that's no good. Like that's really no good. Especially if you have to have a failure, which you have to debug and you have to look at, and you have to then go change the test, and then you have to go rerun it. There are human process ways around that where you have the person who's responsible for making the change has to go do it, but it creates the test tooling that is generating errors that are anywhere between 60 and 97% of the time are false errors. When you get a lot of false errors, people don't trust things, and they just turn it off and they go to ignore, and all the money you've invested becomes no value, and you're setting yourself up for a reputation collapse event. Because eventually someone's going to turn off a check that was actually important, and someone else is going to actually break it on a build, and it's not going to get noticed. And you're trusting your automation because you have this amazing automation. You don't need humans. So what can we do about that? There's a couple of things we can do. One is we can have a dial. So the visual tools are pretty good at this new generation of tools, the visual tools that exist today. Some of them are open source. And you can say, don't look at the whole region, but this thing over here, this should stay the same. This should look like this. You'll still get errors. You'll still get, you upgraded the version of the browser and the styling is slightly different and the pixels look different, and it compares the pixels and says there's an error. You add a human into the decision loop to say, that was okay, that was okay, that was okay, that was okay. And now, instead of, I've got to debug it and check the code and check all the assertions and this kind of stuff, now you are just presented with the regions of the screen that look different for a human being to go, approve, 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 approve. Oh, that one's bad, escalate, turn it into a bug. And maybe with a couple of clicks, you can turn that into a bug. And you had before and after images of what it should look like and what it looks like now. It actually will considerably accelerate the process. If you tie that to an automated test case that is small and tight, you can run it to the test case name, run to that point and evaluate it. That's very different than how we started the top of this conversation. So I'm at way over 5 minutes. I'm gonna stop it here. Today's lesson is that we need to find smarter ways to balance what the computers are good at, which is doing the same thing over and over again, which is what humans are good at, is finding problems. And finding a way to move that dial to the right place in the right scenario in the right context for you and your organization could be a key to unlocking high performance. Thanks for listening.